Hi, Mrs. Ramirez here, working Module 2, Lesson 7. And today, the relationship between the visual fraction models we've been working on and making them into the equations. So, working the visual models and putting the equations along with them. So, we've been working that for a few days, but now formally putting them together. Example 1. We're gonna model the following using partitive interpretation. Remember the partitive interpretation breaking into parts. It is 3/4 broken into. So it's 3/4 broken into groups of 2/5. That is our partitive division that we're looking at today. Another way to say it is how many 2/5 in 3/4. So we are going to model it. And they're saying, let's make a tape diagram. They're giving us some of the steps to make this diagram. So, tape diagram. We're pretty darn good at this. We're even using them as our fractions. So here's our tape diagram. It is 3/4 broken into groups of 2/5. So I see it says shade in 2 of the 5 sections. Since what we're breaking is 3/4, then we've got to break it into fifths. So our tape diagram, we're going to make fifths. 1, 2, 3, and 4, 5. Fairly even there. Awesome. So 2/5, and it says shade in 2 of the 5 sections. Okay, I've got my color. 2 of the 5. So let's label. This is 0/5, 1/5, 2/5. There's my 2/5. 3/5, 4/5, 5/5, which is our whole. There's our giant one. So 3/4 broken into groups of 2/5. How many 2/5 in 3/4? They're saying that 3/4 is what 2/5 is. So this is also equal to 3/4. So what I need to do is find out what's half of 3/4. That's difficult when it's in fourths and I only have 3 of them. So what I'm going to do is I'm going to find half of 3/4 by renaming 3/4 by, let's see, if I multiply it by 2, if I multiply 3/4 by a giant one of 2, I can work with it easier. I will have 3 times 2 is 6. 4 times 2 is 8. When I have 6/8, I can now break that up evenly and easier. So 6/8, I'm going to take my 6/8 and divide it by 2. So therefore, that would be 3/8. So let's see, 3/8 here, 3/8 here. Yep, that equals 6/8. So how many 2/5 in 3/4? 3/4. I've got 2 sections of it and they all equal 3/8. Therefore, for the rest of my tape diagram, when we're dividing and multiplying, all parts have to be the same. Do you see how this is kind of one of our double number lines as well? The parts also mean a little bit, the same section can be named 2 different things. So, let's see. Label the part that's known as 3/4. Yep, we did that. Make notes below on the math sentences. Let's finish up our tape diagram, then we'll work on making the notes. So, okay, so if this is 3/4 broken into groups of 2/5, how many 2/5 in 3/4? They're saying 3/4 is equal to 2/5. I broke that up And then I've got 1, 2, 3, 4, 5 groups of 3/8. So if I have 5, excuse me, 5 groups of 3/8, I'm now going to, let's see, 3/8 times 5, 5 groups of them, 5 over 1. 3 times 5, giving me 15. 8 times 1, 8. 15 eighths. So 3, 6, 9, 12, 15. Yep, that makes sense. And 15 eighths. Well, that's a number that is greater than 1. So therefore, I can take out one giant 1 of 8 over 8. I can't take out a total of 2, though. So there's one giant 1 of 8 over 8, leaving 7/8. And so if I have a giant 1 of 8 over 8 and 7/8, that means 1 and 7/8. So looks like that it's 15/8, and that equals to 1 and 7/8. Okay, so let's find out. Make notes below on the math sentences needed to solve the problem. Oh, okay. We've done a few of those. First of all, we made the how many 2/5 in 3/4? There were 2. We found half of 3/4. That was one of the first things we did, didn't we? Oh yeah, we had to make 3/4 into making 2 of them. Yep, this was first. So make notes below on math sentences needed to solve the problem. First, we did 3/4 and made it usable to break into 2 groups easier. Okay, then we took 6/8. We didn't write it down, but we took half of it, so divided by 2. 6/8 divided by 2, giving me 3/8. So that's what I labeled all of my parts in my tape diagram. Then what did we do? We took, this we actually wrote over here. Then third, what we did was took 3/8 and saw that there were 5 groups of them. 3/8 groups of, or 5 groups of 3/8, commutative property. I could multiply it there. We found that was 15/8. Okay, then lastly, we made our improper fraction into a mixed number. So we took 15/8. Wow, we did lots. Didn't even think about it. 15/8, we made, we pulled out a giant 1 of 8, leaving 7/8. Therefore, it was 1 and 7/8. So we had all of those things. If you like the common denominator way of dividing, I'll also show that. I happen to like that one as well. If I take 3/4 divided by, broken into groups of 2/5, I can make a common denominator of 20. So 3/4 times what equals 20 times 5. I'm adding it to the math sentences that I did. 15/20 is equal to 3/4. Okay. And we're going to break it into groups of 2/5. But if I make it a 20th, oops, 5 times 4. 2 times 4 is 8. 8/20 equals 2/5. 15/20 broken into groups of 8/20. So how many groups of 8/20 in 15/20? Okay, so there's one full group of 8/20 in 15/20. So one full group of 8/20 and 7 of the 8 groups needed for the next group. That's how the copy dot flip works to have the denominator right there. We've got 7 of the 8 groups needed for the next group. Okay, so relationship between the fraction models and the equations. Happy learning!